everyone, welcome back to the channel. So in this video we are going to see three different prompting methods: 0, 1 and few shot prompting method. We are also going to see the comparison between prompt and fine tuning, and these three methods I'm going to try to implement in the same video. So before we start exploring these prompting methods, I just want to give you the reference paper. You can refer this paper. The paper name is Large Models Are Few Short Learners. This paper is from OpenAI. If you want to learn more about the methods that I'm explaining in this video, you can refer this paper because they have explained a bit more in the paper. Okay, now let's start. What is a prompting and fine tuning? So it's very obvious question. Do we need to do prompting or do we need to go for the fine tuning? So before studying the prompting method, I think it's very important to check the comparison between prompting and fine tuning. So prompting means providing a specific input or instructions or task or contextual information to an LLM to guide its output without changing the model's basic parameters or weights. How it works, we are also going to see in a bit. And what are different types of prompting techniques that we see? It's a 0 shot, 1 shot or few shot prompting techniques. So that we are going to see in a bit, so I'm not going to explain them now. What are the advantage of the prompting? It's like it doesn't need retraining, okay, so which means the model can adjust to wide range of tasks without adjusting or tuning its parameters or weights. It doesn't require the training. It's a fast and flexible, so user can create its own prompt and fit different use cases quickly. With that, we can also see some limitations. So limitation in terms of performance: it is low in performance. The model is controlled by pre-existing knowledge. So if the model is not trained on certain task or domain, it may give you false answers, so it may not perform as you expect. Then prompt engineering also required. So creating effective prompts is very important in this case. It requires a number of experimentation, and it can be a bit tricky when you go for the complex task development, okay. Whereas fine tuning includes retraining the large language model on a smaller task specific data sets, updating its parameter or weights to adapt the model to specific task or domain. So there are some advantage. Fine tuning actually allows the model to specialize in a particular domain. For the handling legal documents, you can fine tune the LLM model. Then second is improved performance. Of course, fine tuning usually perform better on a specific task compared to the model that depends completely on prompting. And we can also see some limitations with the fine tuning. As we are updating the parameters of the model, it requires the additional resources. Also you can see the overfitting risk while doing fine tuning, because if you provide data say too small or too specific to LLM, model can overfit and lose its generalizability. The another thing that I can see that it's a time consuming, because fine tuning takes significantly more time. So some methods of fine tunings are PEFT and LoRa. Now let's explore the key difference between prompt and fine tuning. I think it's important to see. So more about first feature that we can see, it's a model parameters. As I said, in prompting you don't need to update the model parameters, but in fine tuning you need to update the model parameters. Task adaptation, yes, in prompting it is done by creating input prompts, okay. In fine tuning it is done by training on a specific task. About time and resources, of course prompting is quick and easy, and as it doesn't require retraining of the model. And in fine tuning it requires data, time, computational power for retraining, so it's expensive. In fine tuning is expensive in terms of time and resources. About task specialization, prompting we see that it's a really general purpose and can adapt to multiple tasks, but whereas fine tuning is really specialized for a specific task or domains. About use case, prompting is dynamic and flexible task. Fine tuning is really targeted, focused, performance optimized tasks. In terms of performance, we see that prompting is low in performance because it depends on a pre-trained large language knowledge base. Okay, while we can see that fine tuning is better in performance for specific task, there is also the risk factor that we need to consider in comparison. So prompting is limited by the quality of the prompt, that is the risk. And with fine tuning we can see risk of overfitting. As I said, we need, because for specific case study, if we provide a small amount of data, there is high chance of overfitting of the large language model. Okay, after this comparison, I think it's important to check how traditional fine tuning works. Okay, so here we will see the training process of the model, where it is given various tasks and continuously updates its internal weights, or we can say parameters, through gradient updates. And this is a repetitive training process. Here I would like to provide a visual representation of how training happens in traditional fine tuning of large language model in steps. So the first step is like a example or task number 1. So here the model is given an input and output pair. Okay, this is the example, first example for the model to learn. Okay, next step we can see gradient update. So after completing example task number 1, the model performs a gradient update, and this is a step in learning process where model actually adjusts its parameters, or you can say weights, based on the error it made while learning the task, and therefore the model is able to improve its performance. Next we are going to provide the example number 2, and the model is again then we will have the another task, and this will help model to learn further. Then again in the fourth step we are doing gradient update. After each task the model receives the another gradient update to adjust its parameter and continue learning from its mistakes. And this is the repetitive process. We left the output incomplete because here the model is, we believe that model is capable of generating a response based on what the model learned before, using n number of examples. So this in summary you can see that model is trained via repeated gradient updates using large corpus of example tasks. Now it's a time to check prompt. It's very simple. When a user inputs a prompt to the large language model, LLM processes this input by analyzing the text and context that user provided, and then model generates a response based on its training and the specific instructions if provided within the prompt. Okay, and this is a step-by-step processing. Now we will see the very first method, because in this video our focus is on prompting method. So the very first method that we are going to check is a zero prompt method and its implementation also. So what is zero shot learning? The model, it's a method where model can generate a response only based on the specific task description and prompt. Here we are not going to provide example or any additional training, which means we are not doing gradient updates in zero shot learning. In this example you can see translate English to French. That's our task description to the LLM, and we want LLM should translate cheese, which is in English. We want this to be translated into French. So in short you can say in zero shot, no gradient updates or no additional training are required. The model does not adjust its internal weights or parameters during training. It simply uses its existing knowledge base. Now we will see the methods implementation. We are going to use the Google Colab for its implementation. So let me open the Google Colab. So in this notebook, I will walk you through installing libraries, loading dialog datasets, encoding, decoding tokens, and summarizing dialogues using large language model. The same notebook we will be using for the implementation of one-shot and few shot learning methods also. Right now we are going to see zero shot, but before to go into implementation of zero shot learning, we have to see few things like installing, importing libraries, dialog datasets examples. So what are these examples? And then we can also see how to do tokenization and few things like a summarization of dialogues with and without prompting techniques. So let's start with the installation and importing libraries. So here are two things: install datasets and transformers. So this code cell installs and updates the datasets and transformer libraries, which are essential for working with a large scale dataset and pre-trained language model. So I'm going to run the cell. The dataset is a library that provide us easy access to wide range of datasets from Hugging Face, I would say, while transformer provides a collection of pre-trained models that we are going to use for a task like text summarization, translation, and many more. So it will take a bit time. So after installation of some packages, we are going to import some important libraries. So these libraries contains auto model for sec to sec LM. This library automatically loads a sequence to sequence model like T5 or BART for the tasks such as task generation and summarization, and autoencoder. This one, it loads a pre-trained tokenizer, and the load dataset would help us to load the datasets from the Hugging Face library. Then there is a generate config. This actually allows customization of text generation process, such as controlling maximum number of tokens or temperature. So this is more or less about the libraries. So next is to access dataset. Okay, this cell actually loads a dialog sum dataset from Hugging Face. Okay, you can see the URL. This dataset contains dialogues and the corresponding summaries, which we will see later. We will use these to evaluate the model on summarization tasks. So after loading the dataset, the next step is to load model. Here we are going to use a FLAN T5 base model. This will load the models and we are also loading the tokenizer using tokenizer.from underscore pre-trained. This auto model for sec to sec LM, this library actually loads, as I mentioned, the pre-trained model, and which is designed for the sequence to sequence tasks such as a summarization. And so next we are going to see some examples from the dataset, dialog datasets. I'm going to run this. This cells actually selects two dialogues from the dialog datasets. They're using indices 1 and 15, and it prints the dialogues along with the corresponding baseline summaries. Okay, you can check these the dialog datasets on Hugging Face library from here. So you can see there is ID, dialogue, summary, and topic. We are going to see the dialogues and its associated summary using this piece of code, and here it actually printed example 1 and example 2, as we are passing only two indices 1 and 15. So here our goal is to show the original dialogue, right, this one, and its baseline summary, okay, which is generated by the model. Here this dataset underscore dialog text, this line of code will print actually will access the dialogues at a specified index from the test set, and the index that we passed is 1 and 15. Okay, and this line of code will assess the human written summary for that dialogue. The output that you see here, it's a 2 dialogue example along with their summaries. Okay, next is to check the tokenizer process. This is the code for checking tokenizer. This cell shows the process of tokenizing, which is like converting a string into token ID, and decoding means converting token IDs back to the a string using pre-trained tokenizer. Okay, this code will convert the dialog that we are passing, where are you from, and this dialog is encoded into token IDs and return the result in the tensor. Okay, and the next, this line of code will decodes the token IDs, which are these, back into human readable string, which is where are you from. Okay, where we are passing the skip special underscore tokens is equal to true, which means like it ensures that any special tokens like end of a sentence are omitted from the output, and this output shows that both tokenized form and the decoded form of the dialog. So next is to see the dialog summarization without prompting method, and this is the code for that. Here I just want to show you what would be the output without passing any prompt. Just we would like to print the dialog and its associated summary, and the baseline summary, and the model generated summary. So here we are considering the same indices like 1 and 15, and we are printing the input dialog, and then baseline summary, which is human generated baseline summary, and then Flanty based model generated summary, and the same for the example number 2. But now the purpose of this notebook is to show you how zero shot prompting technique should be implemented. So for that we need to use this piece of code. Here I'm also using the same dialog indices 1 and 15, but one thing that you can notice from the previous one, here I'm not passing any prompt, just input and output, dialog and summary. But in this, in one zero shot prompting, I'm passing the prompt, what was the conversation, please summarize in the 3 lines. Okay, and then the rest of the things are same like before. So this is the text summarization using zero shot prompting technique. And let me run this cell. Zero shot, as I mentioned, that it generates the summary for the test dialogues without providing the model with any prior examples or training on these specific tasks. Okay, so, and in output you can say that this input dialog, the baseline summary from the data set, and the summary generated by the Flanty T5 model. Talking about zero shot performance, the model actually successfully summarizes the summaries, the dialogues without any examples, but they are slightly different in phrasing and focus. So if you read in detail the response from the model, you would know that they are really slightly different phrasing and focus. So that's why it's important to go for the one-shot prompting. The next method is one-shot learning. It's a method where model is given a task, also provided with one example of how to complete the task before generating response. So task description is a translate English to French like we have in a zero shot learning, but here we provided one example and we provided prompt also. So we want that LLM should translate cheese into French word. Okay, so the key characteristic of this method is the model is given with one example, and before generating, of course, the task, before performing the task, and the model uses its understanding of task and the example to generate the correct translation for a cheese word. Okay, similarly to zero shot learning, there is no gradient updates are performed in the one shot learning, and the model does not adjust any in its internal parameters during the task performance. Okay, it only uses the provided task description and the example. So you can say that in addition to the task description, the model sees a single example of the task and no gradient updates are performed. Now it's a time to see its implementation in Google Colab. So as I said before that the same notebook will be used for the one-shot prompting and few-shot prompting technique implementation. So now we will see the one-shot prompting and we will continue with the same notebook. Okay. This function actually defines one-shot prompt for the model by providing with one dialog summary pair as an example. So this one, the example underscore index for one shot dialog summary pair example. Okay, and this one, this argument represent the index of new dialog that the model needs to summarize after seeing this example. Okay, and this function actually constructs a prompt in this format. First, the model is given one example dialog and its corresponding summary, and afterwards the model should model is instructed to summarize the new dialog. So we are expecting new summary from the model. Here I'm just setting one example index and its dialog to summarize. So example index for one shot is 11, which means here we are passing 1, and the dialogues index to summarize is 200. Okay, so we want summary of these indices, and this is here we are calling the function that we defined in this cell, and we are just going to print it just to see what is inside the this variable. Okay, so we can say dialog, then summary, and now it's a time to summarize this dialog, which is at indexed 200. So we want the summary of this. Here we have this code, and this code compares the baseline summary, okay, with the one shot summary generated by Flanty model. In output we can say after generating the summary, the code actually prints the input dialog, the baseline summary, and the summary generated by the Flanty T5 model, and the output would look like this one. So here we have this is the some dialog that we provided, and this is a baseline summary, and the one shot summary by Flanty T5 model is this one. So person 1 recommends adding painting program to the software. Person 2 suggests adding a CD-ROM drive. So if you read carefully these dialogues, then you will understand this is more or less acceptable output. Now it's important to see the theory of few-shot prompting, and then we will see its implementation afterwards in the same notebook. Now it's a time to see third method, that is few-shot learning, where the model is provided with several examples of how to complete the task before generating response. In one shot we saw one example, in zero shot with no example, in few shot we provide more than one example. Of course, in all of these learning methods we provided task description, it's compulsory. I'm talking about few shot learning. The task given to the model is a translate English to French, and the examples that we provided, there are 3 examples. You can see Sia Otter, Peppermint, and Flush Giraffe, and we want French translation of cheese word. So the key characteristic of this method is that model is provided with multiple examples before performing the task, and these examples help the model to better understand how to complete the task. The model also generalizes from the examples that we provided and uses that knowledge to generate correct translation for cheese word. This method is similar to zero shot, one shot learning. We don't need to update gradients here already. We don't need any additional training here in few shot also. So the model's internal parameters are not adjusted, and it uses just the task description and few examples to complete the task. So in summary, you can say that in addition to task description, the model sees a few examples of the task and no gradient updates are required. Now it's time to check its implementation. This is the function which defines a few short prompt where the model is provided with multiple examples of dialogues and summary, and before asking to generate a summary for a new dialogue. And this you can see here example indices for a few short. Here a list of indices for the example dialogues are provided to the model. Okay, and these dialogue index to summary for a few short. The index of the new dialogue the model needs to summarize after seeing the examples that we provided. Okay, so prompt constructions, here you can see that we add the multiple dialogue summary pairs, for example 2 to 3 examples to the prompt, and providing the model with an instruction to summarize a new dialogue. So here we provided dialogue and the summary. Okay, this is the prompt, and then we ask that now summarize this dialogue. So the new dialogues has to be summarized by the model considering the examples. In here I'm just passing the example indices 1, 15 and 55, and I would like that the model has to give me a summary of this dialogue which is at index 200. And here I'm just calling this function, and that's all. So if you see that dialogue number 1 and the summary, dialogue number 15 and the summary, and dialogue number 55 its associated summary. Now summarize this dialogue. So this is the dialogue we would like to the summary generated by the model here. Okay, for that we have to write this code, and using this code you can see that model is able to generate the summary for the dialogues that we provided. So we can see in the output that dialogue and baseline summary and the summary generated by few short techniques are printed, and the summary is person 1 is going to create his own company. So if you read carefully this conversation, you would know that this summary is perfect summary. What we did here, the model was given multiple examples, that is 1, 15 and 55. Okay, these are the examples that we have given, and we ask summary for the example which is at index 200. In summary, I can say that zero shot learning actually learns where the model was was tasked with summarizing dialogues without any prior example. In one shot, the model was given a single dialogue summary example before summarizing new dialogue. And in few shot learning, what we saw, the model was provided with multiple examples to learn from, and resulting in a better summarization quality. So throughout the notebook, different techniques that zero shot, one shot, few shot were used to test how well FLAN T5 model are able to generate accurate summaries for the dialogues in using dialogue sum data set, and the results showed that improvements in the model performance as it was given more examples. So it is progressing from zero shot to a few shot learning techniques. So that's all for this video. I hope it is useful. These techniques are useful. You also saw the comparison between prompting and fine tunings. So in next video I'm going to cover how to fine tune large language model. So stay tuned for that. I hope you like this video. Please subscribe to the channel. If you have any questions, query related to the content that we saw in this video, please leave them in comment section. The notebook link is given in the description box. So thanks for watching the video, and see you in the next video.